Okay, so we finally get to an organ system. So let's talk about the integumentary system. Integument, base meaning, just means covering. So our integumentary system is the covering. It's our skin, our hair, the things that you can actually see when you're looking at somebody. Now, one of the reasons that we study this and one of the reasons that it's so important that we understand this is because it is, for all intents and purposes, easily observable. We can see it when we look at a person. And there are certain conditions where it makes it very easy for us to diagnose problems. So it can be used as a diagnostic tool. Diagnostic, fancy word. It just means diagnosing. So don't let the terminology freak you out. But think about it this way. If you see somebody and their skin looks orange and their eyes look yellow and they've got that discoloration going on, you know something is wrong. And that's jaundice. That specific characteristic is usually indicative of liver failure. Something is happening with the liver and it's not cleaning the way that it should. So the waste product that is getting through is making the person look orange. Same with if you see a baby and their lips are blue. One of two things could be happening. Either that baby is really, really cold or they're suffocating and not getting oxygen. But again, it's the color of the baby that kind of gives that away. Now, the functions. FYI, I really like to ask you about functions. So it's a good thing to know the functions. Just in case you're not sure about the functions, it's a really good idea to know the functions because the functions are really important to me for you to know. Functions. All right, so there are 5 functions when it comes to our integumentary system: protection, sensation, temperature regulation, vitamin D production, and excretion. And while your book kind of goes into some of that at the beginning of the chapter, I'm going to kind of mention them here, but they will make a heck of a lot more sense toward the end of the chapter after we talk about all of the parts and pieces. So let's talk about the skin itself. The skin itself is made out of 2 layers, the epidermis and the dermis. And we're going to talk about those 2 layers, and we're going to talk about the differences and how skin color comes to be and all of that. So, epidermis versus dermis. If you look down here at this figure, you will notice that the epidermis is kind of right above this scallopy edge here. See the scallops here? Pretty much from the scallops up is going to be the epidermis. Let me change colors. Would this work better? Not really. Take 3. That works a little better. So you've got that kind of scallopy edge. That's the difference between the top of your skin and the bottom of your skin. Now, this area here is going to be your dermis. This is going to be the bottom of your skin or the base of your skin. But push comes to shove, your skin only has 2 layers, okay? So the epidermis, epi means above. And as you can see in the picture, the epidermis is above the dermis. It is the most superficial layer, and it's made up of epithelial tissue. Now, think back to chapter 4. Epithelial tissue covered surfaces. Your skin's a surface. So this makes complete and total sense when it comes down to it. Now, the other thing, because it's stratified squamous epithelium, you also have the ability to resist abrasion. That's why you can get in the shower and you can loofah in the morning and it's not going to end up with you losing all your skin, because this part of your skin literally helps to keep your skin intact and protect the underlying things in your body. Something else that it does, it reduces water loss through your skin. Your skin is oily. Even if you tell me, oh no, Miss Williams, but my skin is dry, go touch a window. Go touch any type of stainless steel, anything. I will bet money that you will leave fingerprints behind. Right? It's one of the reasons that I hate stainless steel appliances, because the minute you touch them, fingerprints everywhere. So we do have oil in the cells of our epidermis, as well as what that epidermis is made out of, which is keratin, which we're going to discuss in a little bit. Both of these things work together so that the moisture within our body doesn't just evaporate away. Now, the dermis, that second layer, the bottom layer that's down here below that epidermis, this, of course, has the epidermis sitting on top of it, but this is connective tissue. Remember when we talked about the dense, irregular, collagenous connective tissue, and I talked about a kid coming up and going, mine, let me show you, and pulling your arm and twisting your arm and going back and forth and all of that? That's what this is. So you've got all of those collagen fibers going in 100 different directions so that everything is anchored down. So when it comes to the structural strength of our skin, what keeps it in place, it's actually the dermis that does that for us. The dermis is the one that I can come up and, take your cheeks and go, ay, que linda mama or papa or whatever. And I'm not ripping your skin off, because the dermis actually holds it in place. It anchors it down. Now, epidermis. Epidermis is stratified squamous epithelium. Okay, so we've got a bunch of layers of squished cells. Remember, stratified, a bunch of layers, squamous, squished cells. And they're separated from the dermis by a basement membrane. So if you look at this picture, if I can get it to zoom like it's supposed to, do you see that red line right there? That is going to be your basement membrane, and it's going to hold these cells to this. Before, I described the basement membrane as being double-sided sticky tape. So it basically holds the top to the bottom. As far as the epidermis goes, as far as this layer that you see goes, it's not really very thick. It's different thickness around your body, but it's not going to be like 3 feet thick. It doesn't work that way. One of the reasons that it is not thick like that is because of this. There are no blood vessels in your epidermis. Think about it. All of these cells that are up here are designed to basically tear off when I rub up against anything. If my clothes rub on the surface of my body, if I loofah in the morning in the shower, whatever, this is designed to just kind of break off. If I had blood vessels in there, that would be equivalent to having pipes in a building that I'm tearing down. If I tear those pipes open, you're going to bleed, right? So we have no blood vessels in the epidermis, and instead it has to rely on diffusion to get nourishment. So when you look at these little dudes right here, do you notice these blue and red little tubes that have been cut in half here? You can see them, yes? Those are actually blood vessels. They're right next door to the epidermis, but they're not in the epidermis. And what they do is they diffuse nutrients out. Well, one of them diffuses nutrients out so that the epidermis that's right next door gets those nutrients. And then the other one, when the epidermis has waste, it comes down and actually gets carted away by the other tube, because one is a delivery service, the other is basically a pickup service. So you have to not only rely on diffusion to get nutrients, you have to rely on diffusion to get rid of the waste products that you have as well. So let's talk about the cells that make up the epidermis. We've got 4 different types. We've got keratinocytes, melanocytes, Langerhans cells, and Merkle cells. Keratinocytes. Notice that it is with a K and not with a C. We are not talking about Bugs Bunny carrots right now. We're talking about a protein mixture that has a protein called keratin in it, okay? Most of the cells of your epidermis are going to be keratinocytes. And the reason that they are those is because they produce keratin. Keratin makes your cells hard. Now, I know you're probably going, okay, but I don't feel like brick. Well, you're right, you don't. But I kind of think of keratin kind of like a shrimp shell. If you think about that kind of plasticky hardness, now, this is the thing to keep in mind though. Keep in mind that when we're talking about that plasticky hardness, we're talking about something that is the size of a cell. So if you've got dozens of those, it isn't a big sheet of it like what you see in a shrimp. So that texture that you feel when you touch a shrimp isn't going to be the same texture as your skin, because you've got little teeny tiny plates of these in each one of these little teeny tiny cells that you can see in this picture over here. Okay, so each one of those is filled with keratin. Now, remember we talked about the fact that your epidermis resists abrasion and reduces water loss, right? Well, these cells that are here that are filled with this keratin are actually responsible for that. So if I put, Kevlar or a bulletproof vest on somebody, it's protective, right? Well, these cells are filled with this hard substance. It's protective. As well, it holds on to water. Water doesn't just go through it. Think about taking your boiled shrimp shell after you've peeled the shrimp. You can hold water in that and it doesn't go through. As long as you haven't torn it, it'll hold water. Water can't just diffuse through it, right? Same concept. Water doesn't just diffuse through this, and you have so many of them stacked on top of each other, like you see here, that it isn't that easy for water just to go. Sweating is different. I don't want you to confuse what I'm talking about with sweating. And you'll see why when we get to the sweat glands. But when we talk about just mass losing fluid through your skin, it's not that easy for water to get out. Okay, so those are the keratinocytes with a K. Now let's talk about melanocytes. Melanin is the skin color that we have. That is what gives us our hair color, our eye color, our skin color, okay? So they contribute to our skin's color. They give us our skin's color. And if you look down here, okay, see this little brown cell right here, right next to the bottom of these cells, of this stack of cells? That is a melanocyte. Melanocytes make color or pigment molecules, okay? And those are how we get our skin color. Now, we're going to talk about those in a lot more detail in a little bit. So I'm not going to talk about it too much here, but know that melanocytes are part of your epidermis. They're not deeper in your body as far as your skin color goes. Langerhans cells. Langerhans cells were named after somebody named Langerhans. So Langerhans cells, that's an example of a Langerhans cell. They are part of our immune system. Okay, so follow the logic with me. If you'll notice, this Langerhans cell isn't all the way at the bottom down here, but it's not all the way at the top up here either, right? It's just kind of dead center in the middle of everybody's business, right here. Yes? Okay. My immune system is designed to try and preemptively strike against things that are trying to kill us. Okay? So if there is an invader coming in, right? And this guy is up here. What happens with the top layers of our cells with our skin when we loofah? They fall off, right? That's why we loofah. We're trying to get rid of dead skin cells. Yes? Well, we can't have him up here on the surface because then that's like saying, I have an army, and they run off of a cliff. I don't have an army anymore, right? So I don't want them that close to the surface because I risk losing them, right? Okay, now let's say that I've got a village that I'm protecting and I have an army, and I put the army in the castle and my villagers are all in front of the castle. Is my army going to do any good for those villagers? No, right? If I put this cell down here, right next to the cells that start my epidermis, that gives an invader a heck of a lot more access to the inside of my body. It's like saying, I'm right outside the door, as opposed to, here's my castle. Just go with me on my castle journey that I can't draw. Hang on. So here's my castle, right? We're going to say that's a castle. I know I'm a terrible drawer. Just go with me on it though. And inside are all of my people that I want to keep safe. I'm going to put my army in front of that castle, right? So when somebody comes to try and invade, they're in the way. And these guys are safe, right? Think about it that way. This guy, like I said, it's not all the way at the edge, but at the same time, these cells down here that are kind of my first starting cells of my epidermis are being protected because my army, my Langerhans cells, are standing in front of them. They're not just letting anybody in. And if somebody tries to invade, they're going to run into that Langerhans cell before they get to the bottom of my epidermis. And remember, right below my epidermis is where those blood vessels are. So having this cell here is very, very protective. Okay, everybody with me so far? I hope so. So we've talked about the melanocyte and the Langerhans cell and the keratinocytes. Let's talk about the Merkle cell. So the Merkle cell is a specialized type of sensory cell, okay? And it is associated with or kind of linked to nerve endings. So do you see this little blue dude here? And he's got the little heart-shaped nucleus right there. See this yellow crab claw down here? This is going to be a nerve ending, okay? These sensory cells that are in our epidermis are designed to detect very light touch and superficial pressure. So think of, you feel a hair on you. Every person who's ever had long hair in their life knows this feeling of, there's a hair on me, I can feel it. And you start looking, that's kind of superficial touch. That hair isn't putting a whole heck of a lot of weight on you, but you still feel it, right? So these cells that are associated with this nerve ending are there to detect that kind of light touch and superficial pressure, that feeling that there's something there touching you. So again, these are the 4 cells that make up the epidermis. You've got the keratinocytes, you've got the melanocytes, you've got the Langerhans cells, and you've got the Merkle cells.